Okay, students, welcome to the IoT session. Today we are doing a special IoT session due to the prevailing situation in the country. So we were unable to do a physical class for today. So what we have scheduled or what we have planned for today, we'll try to have a good understanding of the practical part using the available technology, whatever it is available. I'll try my level best to explain you. For the intro part, I just took this camera. I'm going to switch to my other camera. I'm going to show you what we're going to do today and what are the components we will need. You people can take a piece of paper or in your notebook. Please note down the steps we will be going through. Okay. Right. I hope my camera is again clear to you. Right. If there is anything, feel free to talk to me. Right. Okay. Yes. So we are going to use today. The idea is we're going to do the practicals, right? So when we're going to do the practicals, earlier, in the class, we were doing IoT in the sense using Arduino as the open source hardware and using other hardware components, which means basically the sensors. In IoT device, those are the main two components because sensors play a very important role in the IoT. Right, so we were connecting some sensors to the Arduino board and we were connecting to a computer and we were making or we are learning how to hook up that component or the sensor with the Arduino board and how to get the readings, and based on the readings, maybe we were turning on or turning off LED, right? So far we have worked with few sensors, right? That knowledge is enough for us to continue the other practicals or the rest of the practicals. So it will be easy for us to do the assignment part when you are doing, right? So for the assignment part, we will guide you, no worries, don't worry, okay? So basically the things that we're going to do today, we might need a breadboard. I'm planning to plug this one directly to the board. So in case if I need a breadboard, I just took a breadboard. DHT11, that means digital humidity and temperature sensor. I'm using a temperature sensor module. So this one has 3 pins. The one that we used in the lab, which had 4 pins, right? So anyways, in that one, 1, 2, 3, 4 pins. First, second, third pin we didn't use, and last pin we used. That is how we were using that. So then we will be wiring up this. Once we wired up this, right? So we will be able to do the work, right? Okay. Then you need, I'm not going to remove this one. So it's not always good to remove and plug the things. I'll just tell you what we have here. I'm just using 2 LEDs in case if I need anything to be done, right? So I'm using an LED, right? 2 LEDs, then the Arduino USB cable. Focus is going there. That's why, right? Okay, right. So that Arduino cable, a breadboard in case if we need that. Yes. And this is the most important component that we're going to use right today. So, we are making use of this is the board. You can see down here we are using the Arduino, right? This is the Arduino board, and here we have the Ethernet shield. So because we are building the full IoT product today, or we're going to build the full cycle, we need our Arduino device, which is going to get connected with the sensor, which is going to get the readings to be able to connect to the internet, So we need a medium through that we can do that. So in order to do that, we are making use of a Ethernet shield, right? Last time while we were checking this, the price was 2,250 plus. So don't know the recent prices of this. For your projects, when you're doing as the group projects, you're going to undertake them, you will need one of these, right? So if you are to do any practical work, if you want to learn how to do that, I'm going to anyway arrange that in the lab. So this is one device which you can use that for, right? So another thing, I'm using a Uno board. Arduino, different types of Arduinos are available. So this is a Arduino Uno type of a board I'm using, right? Then what we need to do next is, right, we can hook up these things together and we can do the rest of the work, right? Already in this Arduino, I have uploaded a program, so it doesn't matter. I'm going to first hook up the Arduino, right? So you will do like this first, right? So you can, before powering up the Arduino, you plug the Ethernet shield cable, right? So you can see this is the port where you will be plugging in the Ethernet shield, right? This is the RJ45 cable, right? Okay, this my RJ45, this cable is connected to my router. So I'm plugging it that here. So you will not see any lights glowing because the Arduino is not yet powered up. The next step I'm going to do is I'm going to connect my USB cable. Then I'm connecting to the Arduino here. Right now you can see my device is powered up, right? So I will leave it like this while I'm explaining. I think that will be enough. I think it's shiny. Okay. Right. So this is how it will be looking by the time we're going to do the work, practicals. So I will be hooking up and I will be doing something, or I might be holding the DHTT sensor like this, so you can see the readings changing, right? Okay. So this is basically, first of all, you don't need to hook up anything to this. You don't need to hook up anything to this. There are small steps that you need to do in the Arduino IDE, that means in the software, right? I hope you have noted down the steps. Step 1, what you need to do is you have to take the shield, then you have to plug the shield, or you have to attach the shield to the Arduino, because students, when you're doing your practicals, when you're doing your assignments, especially when you're doing the assignment, you need to take each and every step of your assembling your device. Every step you need to take photographs. Every step that you have to take a photograph, and you have to write a description for that or a heading. So that is why from the beginning I'm saying, so you will show the components what they are needed. Ethernet shield is getting attached with the Arduino board. Then first you connect the Ethernet cable, then you connect the USB cable, which is provided for the Arduino, and that you connect to the computer, right? I'm using extension code here, extension USB code, because I'm using a normal desktop PC. So the PC system unit is somewhere there. Okay. Then what we're going to do is, step 2, what we're going to do is, I can take my screen sharing part now. I need to do the screen sharing part. I need to explain you something now. In order to do that, I will share my screen. Wait. Hope you can see my screen, which is shared down, right? The video. Do you still see my video?
Screen share only.
Practical video still you see there, right? Good, right. What we do is, now we're going to use this one, right? Adafruit website. When you go to Adafruit website, step 1 that we should do is we should have created an account in Adafruit. I have already asked you to do that one. Most of you would have done it now, right? You would have done this one, so we can continue without any issues. Right. Step 1, if you are step 1 means the next step that you are doing in your book. If you're noting down, you can say that is you can sign in to your what do you call this? Adafruit IO part. We are signing in. So I have already have an account. So I'm going to use that username and password. My screen is visible to you, neither. Right. Let me do something like this. I'm going to stop this video, my video, right? So for temporarily, I have stopped the video. I think you can see the screen there. Okay, my video is there, fine. What we're going to do is we're going to log in using our username and password. Make sure you have a proper username and passwords. For a long time you can use this one, right? And we have signed in to a free account which is provided by the Adafruit. So which is provided by the Adafruit. We go to a free account. So last time I have visited here, right? So it takes me up here. Nuzrath is my user name, and I'm in my dashboard. You can create several number of dashboards, right? So if you go to the profile, I will explain you. I didn't explain this neither to you. Today I will explain you what is Adafruit and how we can make use of this. So if you go to my profile, you know, you can see current status. It is showing that I'm using a free account, right? Free usage. So groups I can create 1 of 5, or we will see what is a group, right? That is not much necessary for us now. Wiper Snapper is a new feature that they have introduced. Feeds, of course, we're going to talk about this, right? I'm going to talk about this immediately after I create the program. I want to tell you here, for your free account, you are capable of taking 10 feeds. 10 is the limit they are giving for you. 10 feeds you can take. Out of those 10 feeds, I have already used 6 of them, right? I have used six of them. I can create another 4 feeds, right? So 4 feeds. By the time you are doing your assignment, if you are doing all the testing feeds, if you do a lot of testing feeds and all, I recommend that you delete them. You delete them properly. After you delete them properly, because you have to do the screen recording and everything, you have to do provide evidence. So properly, you can create one proper feed for your assignment. I will tell you what is a feed after I get this one, right? Right. Then we have a dashboard. I'll show you what is a dashboard now. And we have another thing called rate. Okay, it says 30 per minute, 30 per minute. Okay, I'll switch to my other camera. You see both, neither my camera and the screen, you both see neither. Now children, we have the DHT11 sensors with me. So if you are getting readings from this sensor, what's going to happen is these readings, now we know in Arduino, we set something called delay, right? So we make the device idle. Idle means it doesn't work, or it doesn't send data, or it doesn't do any processing for a certain number of seconds. We can set that. That is what we do when we make the Arduino device. When we put a delay, then it becomes temporarily inactive. So if you don't put any delays here per second, you can, because computers are capable of sending thousands of instructions. So we need to make very sure that per minute from these readings when we are taking, we are not taking more than 30 readings per 1 minute. Okay, so that is what you meant by rate. 30 per minute means we can take readings 30 for 1 minute, because this is a free account. Okay, I will connect this one with your feeds in a while. Just give me a few seconds, right? So they say current usage. Now there are no any active IoT devices connected to this IoT. That means this Adafruit platform now. That is why this is saying 0 per minute feeds are coming now. Then they are saying storage per 30 days. That means that they now, you know, we will be using the sensors, we will be using the microcontroller, then we are using a programming language to get all the things, and we will be using Ethernet shield to get ourselves connected to the internet. Through that Ethernet shield, we're going to send the readings from the temperature sensor to the cloud, or the platform we're going to send. In the cloud platform, we're going to receive this data, and we're going to record this data. So now, for example, now if you are in a real world environment, if you're testing this one, let's say your device, IoT device is running for 1 week. Okay, without a problem, for 1 week, you can capture all the data. For 1 week, you can capture huge amount of data for your testing purpose, I'm saying. But if you want to run this one for about 6 months, continuously want to run and do the things with this free account, you can't do that, because after 30 days, your feeds data will automatically get reset. So that limitation is there. So when you are doing your practicals or the assignment work, you have to run your device for a particular number of time. Once that's finished, you need to make sure that you download the data for further processing. If you just leave it there, after 1 month, it will be automatically lost, right? So that is, I just wanted to mention about the account that you are having here. Right. Now, children, this is just one IoT platform or cloud platform what we are using, where we can get the data from our device, then we can process it, we can visualize it, and even based on that, we can do some triggers. I will show you that if some condition is met, how to make an action happening. For example, if a particular amount of temperature reaches or it goes above in your mobile phone, you can receive an SMS, or you can you can get an email to your email account. You can do certain things. Not only those are basic and easy ones. We can do further things as well. So all those things can be done from here. So now we're going to take a look at the other pieces here. So when you go to the profile here, you see home, public, monitor, activities, it's showing that. So what we are interested in the profile, we will be going to the feeds section. When you go to the feeds section, now you can see I already have 6 feeds like this, right? There are 6 feeds. Now you can see college humid, college temp. These are 2 readings. Actually, a feed means a reading that you take from a sensor. That is what we basically call it as a feed. Okay. So last week, I think I was taking some readings from during my college time. I was doing this one. So that is why I have said college humid, college temp. So if I open this college temp feed, it will show the data, how it has been or it had been captured. So inside that, you will see a graph like this. And there seem to be, you can see this is actually a graph, children. Because you know, inside the coordinator's cabin, I did this one. The AC was also turned on, and the room temperature was 27 centigrades. So here, by the time 4:03, I think I have started to take the readings, and it has gone up to 4:49 in the evening, or 4:54, till the temperature has not changed. The temperature is same. So 27 centigrades itself. Now today, when we are practicing, we will blow some hot air to this one. So we will try to change the temperature. And we can see there is a fluctuation ups and downs in this graph. Actually, we will be getting a nice graph here. So let me go to another feedback, and we'll see, right? I think this is what I did with my nephew. You can see here there's a drop, sudden drop. There was a wiring problem here. You can see -999 comes if there is a wiring problem. Then the first reading that I have got was 46, strange, okay? And it has gradually dropped. I think I was holding closer to a lighter or something. We tested like that. That's why it's very hot. And it's gradually reducing up to like 31, 30, like 29. In my room, usually it is 30, 31 here, right? At Maunella, 30, 31, sometimes 32, 33 also coming. So that's the normal temperature here. So it is, you can see after 29 here, slowly going here, then has gone to 31, and it has dropped again to 30. Likewise, the values are coming. At some places, 2 decimal place values also have come. 29.89 have also registered, right? Okay, so this is what a feed looks like. Okay, this is what a feed looks like. So this is, if you can do up to this point, you are completing around 60-70% of your tasks in your assignment. So once you're starting to get the feeds here, it will keep on recording your feeds like this. Then what you need to do is, based on this data, we need to do your analytics. You know what is analytics, right? So you're going to process that data. So you can do it two ways. One is you can download this data into a CSV file, and you can use even Microsoft Excel to draw the graphs and other things. You can reconstruct all these things again, right? In Adafruit environment, what you see in the feeds is, it's a nice thing. You usually get it in a feed, you get it in a graph like this. So this kind of a graph will be again necessary. It will be useful when you are doing your data processing. That means when you're doing your analytic work, you need to do this one once again, right? So once you download it, so Adafruit automatically does that for you. But actually for the assignment, you have to download the data from this feed, and you have to analyze it, that using a tool like Orange, SPSS, or even you can use Power BI. I think you have learned about Power BI software, so you can make use of the Power BI software. When I'm talking about the assignment, I will thoroughly give you how to write the project proposal, how to create the proposal. In the proposal, what sort of things should be there. Then why you selected this particular proposal out of the other two proposals. You will give reasons for that, like that. And how you're going to build it, you will give a block diagram. Block diagram means just a component diagrams, how it is connected. Those will be there in your proposal. Then there are steps will be coming. You will be showing a step by step the design. Then you will show how the implementation is done step by step. The photographs will be taken. Then step by step you will be recording the things, and you will be having a video record of the device which is functioning, so on and so forth. I will help you how to do that part as well. Okay. So just the idea here, once you go to the feeds, you can download this data as well. I'll just download and show you, right? So download all data. You can download it as a JSON file. JS means JavaScript on nodes. This is the JavaScript way of downloading data, and you can process them as well. You can download it as a normal one, which is the CSV, which is, you can simply open that data with what do you call Excel. Okay, so here there is a restriction, something coming. We'll see. You can now only download complete feed data once every 10 minutes. Please try again after 9 minutes and 29 seconds. There could be a reason for this. To get the fresh link update, okay, click to refresh. Okay, I can't download this one, children, because of this restriction. What do you call that? The free account, that is the restriction. So if there is no free account, we could do that. Right, so here the link is given, right? So we will try downloading that. Okay. Yes, it is giving, right? After another 10 minutes only, they will allow us to download it again. So I have IoT folder here. I'll go to 51. Right, so I'll just download it here. My nephew's name has come. It says Ayash, doesn't matter, right? So I'll delete that part. I'll change it HND 51. Yeah, just this is not the practical. We have to do it again. I'm just saving it. So once that's done, you can see my screen is visible to you. It got downloaded. Then I can open that data once again. In Excel, I can open it. It got opened. You can see I got it here, right? So a unique ID is also getting created. If that is not necessary for us, we don't need to process it. What we are interested in is the feed. This is the value. That's a Celsius value. Some sample data also have gone there. All the data has gone. From here only, temperature started to capture, right? From record number 91, I'm starting to capture that. And you should see this is something unique ID has been given here. Feed ID has been given because maybe thousands of people will be using the platform. So our feeds have been given a unique ID and created at. That's also nice because when we set our time zone properly from where your IoT device is getting connected, So according to that, without a problem, your time nicely can get registered. I'll show you here, my 91st record. That is April 4th, 5:10, 57 p.m. is the record we have started to capture. Then every second, like I was capturing every twice a second, like I was capturing data like that. So how the data has come in those times, you can see here. So if you want to find out at what time the high temperature detected and at what time an error occurred, the date and time is there in the platform itself. You can make use of it, right? So without using any other modules, right? There is a module called RTC module, real-time clock. Otherwise, you have to attach that to the Arduino device, and you have to send that time also as a separate reading. Okay, right. Okay, I hope you got a rough idea now. This is what we will be doing up to this point. If we take it, next what you can do is you can simply draw a graph or something based on this and doing some useful analytics on this one. So the device that you're going to build is going to be somewhat very useful than this one. So if you're going to select something like that, and I think you can plot data and I think you can insert into a chart near the right. So let's say I like to put it into a line chart. Right. So you can do some work on that, right? So I didn't properly do that. I will do it and show you later, right? So based on this data, you can draw them some useful information, right? So huge amount of data is here. Okay, right. Let's get back to our practical work, right? So there is nothing much to do in the wiring part. So I have just connected these devices. That's all. Let's go back to the Adafruit part once again. So that is about the feed part, children. And here we have something called the dashboard. Dashboard is very interesting and very easy. You know, I can set up to 5 dashboards. So you can give each dashboard a name. Simply a dashboard means in one dashboard, you can see here there's an example for the dashboard. At a glance, you can see multiple feeds. That means you have IoT device which gets the humidity reading, temperature reading, then say motion detection, then let's say LPG gas detection. What else? So if you have these kind of readings, if you're taking each one, you can design display it in a gauge like this. So these are called gauges. You can design it, you can put them in these kind of gauges. So if I open already created dashboard, if I go there, you will see this is one dashboard that I have done. This is I have done this one actively. This device is not available now. When we connect our one now, you can lively see the readings, right? You can lively see the readings. We will do that. Right. So when you are doing the visualization part of your data, you have to take screenshots of this because you are taking your data and you are processing it. So you can show these dashboard screenshots in your assignment, final assignment. You can show them. That means you have processed them, right? These graphs and all automatically coming. But anyways, you have to produce graphs or these type of gauges using Excel or using Power BI. I think you all know about how to use Power BI. Neither. Right. So this is a dashboard, very simple. So from here you can go and you can go create new block and you can add a gauge. I will teach you how. Once our things are ready, we will do it. Right. Okay. Then we're going to do wiper sniper. I'm not going to do it now. Actions, not now. Services, we're going to do it later. Last part, I'm going to show you the services. In the services, I'm going to go to something called IFTTT. If this, then that. If this, then that. So what you need to do is, you already know I have asked you to create an account in the IFTTT website. So when you have done that, my one is already connected to this Adafruit account. So IFTTT is a different platform or a different environment, that in that you have to create an account and you have to get it connected here. So once you do that, if something is met here, we can if some amount of temperature reaches, let's say you want to send an email, or you want to send an SMS, or you want to buzzer an alarm, you can do that through this one, right? So it's pretty simple and very easy to do. So those are called triggers. So we're going to do that as well. So this is not part of your assignment. This is not necessary actually, but it's better to know that one. If something goes wrong, we can use the triggers to make things happen, right? So that will be enough. Finally, let's see what is the key part. So when you go, that is the yellow color one, when you go key. Now for my user account, this is the username and this is the input, or that means Adafruit key. This is my key for my username. So using this one in my coding, my IoT device can send the feeds. Feeds means sensor readings to the Adafruit cloud platform. It can send it to the Adafruit cloud platform. So that is, I just wanted to mention to you, that's it. Okay. So if you want to regenerate the key, you can do that. But if you have already coded any of your previous work, it will stop working. If you regenerate the key, you will have to highlight the, you will have to update the previous codes that you have done. Okay, right. So this is just a demo, or this is just a walkthrough through the Adafruit website. So what it has and what are the sections and where we will be using. That is what I did. So in the practicals, I'm going to now actually show them how you're going to do that part, right? Okay, right, good. I think you are noting down things, right? You're noting down the things. So our next step we're going to do is we're going to start our Arduino software, right? So let's start the Arduino software. This is something I did last day, I think. Right, let's take a new sketch. Is it clear, children? My coding, is it clear?
Yes, sir. Yes.
Right. Okay. Now, what we're going to do is we're going to go to Tools menu, Manage Libraries. Tools menu, Manage Libraries. Can you remember, children, in the theory part of the IoT, we learned about frameworks, platforms, hardware, software, APIs, and there was one more thing called protocols. We were talking about these things in the theory part. We don't have too much worry about that now. Now, you know, when you have something called a protocol, when one device needs to communicate with another device, it has to happen in a very standard manner, because it programmatically it has to happen. So we use something called protocols. Strictly two devices or those two things need to follow those instructions or the steps so that they can communicate properly. So that is what is the idea about a protocol. So here in IoT, we mainly use two types of right, MQTT and WAP, right? So there are two types of protocols, right? Right. So it stands for, right, MQ telemetry transport. That's the name, right? So you might need that one when you're using your theory part, right? So these things, I will help you how to do that in the assignment, right? So how it is done. We don't need to go too technical in this, right? So we're going to make use of this kind of a protocol that we need to understand, because, you know, when we were publishing websites, we were using something called TCP/IP, that is the core protocol. With that core protocol TCP/IP, we make use of HTTP, HTTPS, UDP, FTP. These were protocols. Likewise, MQTT is the most famous or most widely used protocol with IoT devices. And you are using one more, that is, another one is also available. There's another, it says constrained application protocol. Constrained application protocol. There is another one which is used to work with IoT devices. So we're going to make use of MQTT protocol in our projects. It's really easy, and how to use that, right? MQTT, right? Nice. So the next step, what we're going to do is, as I told you, you went to tools and manage libraries. We are in this one. Yesterday only I updated all my libraries, so there is no update command coming again. Here you have to type, you know, when you're for the first time, you have to type MQTT, right? Let's try whether it is coming. It will come, right? I have already installed it. Actually, you should type Adafruit MQTT library. You can see here, I have already installed it. I'll put the name for you on the screen so you can write it down. Adafruit, note it down. Okay, you have to do this one. Adafruit MQTT library, right? So if you're having your Arduino, you can do it even now. So Adafruit MQTT library, right? So just, it's a small library. You can just get it installed to your Arduino IDE, right? So once that is done, right? Once that is done, what we need to do is, you know, when you want to create an IoT device and when you want to do the programs for the IoT device, you need to do a lot of codes, right? So here, the great advantage with this one is it comes with a lot of samples, and especially for this board, for this particular board, what is this Ethernet shield? If you are using Wi-Fi shield, if you are using the GSM shield, they are using different type of example programs. So we're going to make use of the example program, and we're going to build our IoT device. That's the beauty of this, right? Okay. So carefully watch how it's going to do, how it's going to done. So you go to File menu, then you will go to the examples section. In the example sections, if you go to the down, really down, this area is where we the libraries that we have installed. These are from installed. Most of these things will come up with your Arduino itself. So when you go down here, you can see there are something called Arduino. It's not Arduino, Adafruit, Bus IO, Fauna library, GFX, GPS. These were libraries that I am using. Okay, Motor Shield, right? Motor Shield library. There you can see Adafruit MQTT library, MQ telemetry transport. That is the library that we are looking for. In that, you can see next to that, according to the different type of shields or the modules that you're using. Now, if you're using an ESP32, ESP8266, that's the this one I earlier showed you. This one in the video, you can see this one. If you're using, this is a Node MCU one, then you can make use of these programs to work with that, right? And if you're using a Wi-Fi module like this to work with, I think you can see in my hand what you have, what I'm having. You can use this one, ESP32. See, so according to the device that you use, you can have the program, right? And from there you can build it. I'm going to take, can you see slowly down here, you can see there is a section called MQTT Ethernet. If you can't read my screen, I will read it for you. That is what the option I'm going to open. So when I open this, this nicely comes. Okay. This nicely comes. It is okay even if we just print the code like this in the final assignment, or even if you doesn't matter, you just modify this code. They are just saying this was built by the Adafruit platform, and they are requesting you to buy their hardware from Adafruit website, and their hardware they are making a request to buy. Right? They are giving this software free of charge, and they are asking to buy their hardware. Right? We don't need to understand all this code. Just take a look at this one. This is using 6 library classes. One is there's one called SPI, Adafruit MQTT.h. That's the important one. And Adafruit MQTT-client. These are built-in library classes, or in C, C++, we call them as header files. There's another class they are using called Ethernet.h, Ethernet client.h, DNS, DHCP.h. All these libraries they are using. Don't even touch these codes. Don't even do any changes to this one. If this program to work, it must use this, right? Okay. Let me tell you a small thing here. Okay. You know, there was a earlier I kept it, it's under that, I can't take it again. Just like the shield, I had the Ethernet module was there. Connecting the Ethernet module, I was not able to run this particular example that you are seeing on the screen. You will have to find a different example to do it. Actually, shields are very convenient and very easy to work, because it's just take that, plug it to your Arduino, then do the rest of the wiring and do the project. So you don't have too much manually configuring the pins and all the things. There won't be any issues, because these already the libraries that you're having on the screen, what you see, will be automatically will get configured to these pins and all, right? And you can see, I don't know whether you can see this piece over here. This area, there are pins from 13, 12, 11, and 10. Those pins are underlined in white color and like a box, which means those 4 pins are used by this shield. Those pins are already used by the shield. And you know, there are certain power pins here from the Arduino. Those also being used. And maybe that is how it is getting powered up, this particular board. So that you need to also keep it in mind, right? Okay. So let's keep the device here. Now, children, down here, when we are trying, you can see there is a MAC address have been given to this, right? So MAC is a unique address. The networking guys will better know about this. So there's a MAC address have been given, and each of the MAC address location or the value has been given in hexadecimal values like this. So 0x in Java, I have taught you, 0x means it's a hexadecimal value. So using hexadecimal, they have used it. So D, F, A, D, B, E, E, F, E, F, E, and E, D. That is the MAC address. If I take another Ethernet shield, and if I take it, the same example will come, child. So now, let's say we are doing practicals in the lab tomorrow. I give you 3 Ethernet shields, and you're going to open file example, the same file you're going to open. So all of your MAC addresses will look the same. We will run and see whether our DHCP server can dynamically give us the IPs, and it can, without a problem, it can work. If there is any conflicts, we will try to manually update this MAC addresses, right? So we'll try to update them. Okay, so I'm not going to explain everything, right? So let's go down here. So here, children, now the practical part, I think you're noting down things, so it's okay. You can see AIO, Adafruit input output. So Adafruit AIO server is io.adafruit.com. That's the website part. Just going. And this is the port number. Through that, it gets connected. 1883. Actually, at the college, they have blocked this port. I have asked them to open this port. So tomorrow when we are practicing, if we are not connecting through a 4G router, if we're going to go through the college usual landline, which means the normal local area network, if you're going to connect through, we won't be able to send and receive data using our IoT device because this port is blocked there. Okay. So at home, when I'm practicing, there is no issues. There's no worries in this one. I can simply do that without any issues. Okay. Right. So that's about it. That's about the port number. Then comes the easy part, which says username and the key. So AIO means Adafruit IO, username and key. Now it says we can simply go to the Adafruit website now, and I can go to my key, and you can see this is the same thing it's showing for Arduino how to code that. So my username is Nuzri. So I'm going to double click and copy, come back to my IDE. So I will save this. I will paste this one. I can't. Oh, sorry. I should put it here. I can't save this program. This is a built-in example. I have to save as this. Okay, I will do it. No problem. In this computer, I have a UPS, right? Then this is my key. So AIO underscore, there's a huge characters and numbers are there. So I'm going to use that, copied it. Then I'm going to come in here, right? So my username and my key are both placed here, right? Okay, placed here. How we should do this one at the college is actually, I should do this step. Now you two teams should now complete up to this step. Next, we go to the next step. That's how we're going to do. Now, tomorrow when we come to the college, most probably we can come. So when we come to the college, I will revise this one. 3 teams, you have to do it on your own. Okay, right. Okay. Then comes to run, set up the Ethernet client. Set up the Ethernet client. These things, auto set up the Ethernet client. There is just like from that class, they are just creating an object. That's what's happening. And Adafruit MQTT client, MQTT, and they are passing in the parameters that we created. So it says client, and this is needed for the Ethernet shield Putala. So then the server port, username, and the password. Those are the values that we give. So actually, we don't do any changes to these lines. Okay, we don't do any changes to these code lines. Let's go down, and you can see this is important. Feeds, right? Feeds. Set up a feed called Photocell. This is a sample comes from the MQTT Ethernet example, right? So Photocell need not to be always Photocell. It can be something else, right? So we will have to change this, right? So there is a word called publishing. There's a word called publishing. Publishing means, I think you can see my video as well parallelly. From this, our Arduino, which means from our IoT device, we are sending data to the cloud. That means we are sending data out. We are transmitting. So that is known as publishing. That is the word, right? Then when you want to receive data from the cloud to the device, that means if you want to take something to the Arduino, and by receiving the data, you want to perform something, that is called subscribe, right? Publish and subscribe. So down here, you can see subscribe option is also there. Today, I'm not going to cover the subscribe option. I will do it on another day, maybe tomorrow. So when you receive a value from there, you can make a door open, ring a bell, you can make a LED glow, those kind of things also you can do. This is very simple. This part is simple. First, we're going to learn how to send the data from our IoT device to the cloud platform. Okay, so that is what we are interested in. So there are some small tweaks that we had to do. Tweaks in the sense we had to do some modifications. Now, this example is for Adafruit platform, and maybe this is for a professional account, which means that has no restrictions. So you can send data, you can send data very quickly. You can send data very quickly and you will quickly run out of your limit. What is your limit? Your limit is 30 feeds for 1 minute. So within 1 second, you will run out of your limit. So you will have to wait another 1 minute to send another 30 feeds. 30 feeds. So we're going to avoid that one also. I'm going to show you how to do that. Right. Now, in this coding, I'm going to explain you this piece of part. Subscribe, we're going to do it later, I told you. Subscribe means receiving data from the IoT device from the cloud, and we're going to do something. Okay. We are not going to do it that now. We're going to do the publishing part. You can see it says now we can publish stuff, right? So here you can see there are three serial.print. So serial.print means, you know, if I open this, right? So if I open my this is connecting to this one and it will start sending information because I have already programmed this one, children, and only thing is I have to connect this one. It's already says connected. So you can see in the serial monitor, I'm getting the values. This is, we will come back to this point later. So up here in the setup code, inside the setup code, what we basically do is serial begin 115200. That is the baud rate that we say. This is the bits per second your Arduino as well as the serial monitor will communicate. So if you put, normally we put 9600. So if you put 9600, here also you need to put that to 9600, right? Okay. Right. Now what we're going to do next is, anyway, I will be uploading a fresh program to this, no worries. Let me come down here. Here it says there's a initialize the client serial print. This is just a confirmation for us on the screen. This is good because when you're doing your presentation or assignment, you can change these labels. Let's say your system is something like automated mushroom farm, or let's say automated greenhouse, automated smart house, something like that. If that is your IoT device, you can say welcome to automated smart house, something like that, a message you can put. So those screenshots you can capture later. So ethernet.begin. So I think the shield, they are starting up from here by providing the MAC address, and there is a delay. Give the Ethernet a second to initialize. So I think it takes some time to do that part. Then it says MQTT subscribe. Subscribe means obtain data from the cloud. So we haven't coded this one yet. So it's not going to have much effect on this part. Let's go down here. So there's a variable defined here, uint32t, which means U stands for unsigned. In C++ and C language, there is a possibility to define integers. When you're doing in Java, we just put them as integers, right? But in C++ and C language, you can define variables as unsigned integers, unsigned integers, and signed integers. The difference between that is, if an integer is unsigned, which means it cannot hold any negative values. So this is a temporary value that they are creating, and they have no intention to put any negative values. For that reason, they have set that to a variable called x, and they are setting that to 0. That's what's happening there. Further, here you can see we have a loop. You know what a loop does? It will keep on doing the work. So you can see the MQTT connect function has been called, and I think if it is not here, MQTT connect function is already built here, so that will be called. You don't have to do any coding here. No need to do any changes here. Don't do anything down here, unless if you want to change the labels, because we will focus on the things that is necessary for us now to get started with the practicals. Right. So once we come down here, subscribe, I already told you, if you are obtaining information from the cloud, we are going to use that. Now we're going to send data to the cloud. So we are interested in this particular piece, right? What I have highlighted is what I'm interested in. Nice. Now what we're going to do is, now we can publish stuff. So it says serial.print. If they have put, I think, to format something within double quotations, this is displaying some text on the screen. Then it says serial.print the value of x, which is 0, children. Up here, we already had it. There's a variable called x, which is 0. Let's just put the value 0 there. And it says ... So it will print something on the value, sending value, say 0 ... Then after the delay, it will say 1 ... 2 ... 3 ... It will come like that. Nice. Now comes, it says not Photocell.publish. Now then we will talk about this Photocell thing. Now here in this particular line, in this line, in line number 54, you can see we are creating a feed. This is the name of the feed. That's the object name. Adafruit MQTT publish. This is a class. From that, we are creating an object called Photocell. Okay, Photocell. So always you don't need to keep it as Photocell. We can use a different name and we can easily get it done. Now I'm going to rename this one, right? Let's call this one as HND51. Right. HND51. Let's say first IoT. Too big, neither. IoT 51 we'll put. Okay. Name down, right? IoT 51. IoT 51 for publishing, right? So the same name I'm going to give here. IoT 51. Then children, here take a look at it. What happens is, here notice MQTT path for AIO, follow the form username / feeds / feed name. That means in your website, that in the Adafruit website, this is how it's going to come. So AIO username, that is Nuzri, that is what my one / feeds under feeds, because I can have up to 10 feeds / Photocell. So if you don't change this name, in here, now there are 6 feeds here. You see some names. So I'm going to get something like Photocell here. I'm going to get something called Photocell unless I change this. So I'm going to change that to IoT 51 as well, right? So I didn't save it. I have to save it, right? Okay. So that's all at the change I did. So Photocell, I changed from Photocell to IoT 51, and here also Matakatwa change karana, right? I changed it here also. Then for a time being, we don't need it now. Let's go down. Here we come, right? Now we got it. You can see this, I already talked with you. It just prints the value of X on the serial monitor. Now it says here, if, right? It says not means, what we do is, here we can't say Photocell, we have to say IoT 51. IoT 51 is the publish object. So IoT 51 dot publish. So we're going to ask the our IoT device to send the data from our IoT device to the cloud. So we are sending the data from our device to the cloud, right? So what we are sending is X++, right? X++. So X will be incremented by 1 and it will be sent each time. So if it is 0, 1 will be sent, 2, 3, 4, 5, like it's going to send. Nice. And in front of this, you can see I have put a NOT gate, which means if this is failing, if this is not happening, what's going to happen is this message is going to get printed. This message is going to get printed. What is the message? It says failed, right? Serial.println failed. If this was not successful, if it is not successful, it's going to display as failed. Otherwise, which means else, we're going to say formatted. That means on the screen, we're going to say, okay. So you're simply going to get a value like X, that means 1 dot dot dot, okay, 2 dot dot dot, okay, 3 dot dot dot, okay. That's how you're going to get. Now comes the important part. Now comes here, you need to put a delay, right? You need to put a delay in milliseconds. So which is, I'm going to put 2000 here, because if you put 1000 here for 1 minute, we're going to send how many? We're going to send 60 feeds, which can't do. We can do that because our maximum limit is for 1 minute, we can send, max limit is 30 feeds. So make sure you're going to set this to 2000, which means so twice a second, we're going to send the information so that we can stay in the limit, which is 30 per minute. So if you're going to get 2 feeds, then 2 feeds, that means this is going to get reduced to 4. Why? Because 2 feeds you have to send. At once you can't send both. So you have to publish 2 times, right? So same values you need to publish 2 times. So when you want to do that, you have to set this to 4 seconds. That is this is disadvantage what you have in the free account. Let's put something like 8. 8 means 3 devices, 3 feeds. 16 means 4 feeds. 32 means it's like more like per minute 1 reading, right? 32,000 means per minute 1 or 2 readings. So what will happen is if you have 4 or 5 devices, 5 feeds if you want to take, then this is the limitation. So every 1 minute only you can get a reading. So if you want to very accurately and very quickly, if you want to something happen, that is a disadvantage. So when you're talking about the limitations of this platform, you can talk about that one as well. I hope you understood. No one asked any questions. If you do have asked any questions, please feel free to ask questions. Okay, children, did you understand theory what I explained now? Why I am putting here 2000? Ahlak seems to be not there today. Nirmala, Kavishka, Afkar, Buddha, hello. Afkar, did you understand, Buddha? You're speaking, I can't hear. Another person, can you hear? Inshaf, can you stop to me, please?
We can hear, sir.
Yeah, can hear.
Okay, good. Inshaf, did you understand, Buddha, this part? Inshaf?
Sir, once more, I didn't understand.
Inshaf, you didn't understand this, neither, Buddha. Did you join now?
No,
Or
sir,
the beginning?
No, I joined 9:30.
All right. Okay. Now the thing is, now the IoT device is here, Nepata. The IoT device is here. From this device, we can send information. We're going to send the information to the cloud. In the cloud, we have to receive that. So the platform that we are using is this one, Adafruit IO. So in the Adafruit IO, if you go check your profile, I have a free account here. So the free account, now you can see they have given something like a rate, 30 per minute. What do you mean by 30 means feeds? Per 1 minute, you can get 30 readings. That's all. That's the maximum. So now when we are creating our device, what we have to do is we have to make sure we don't exceed the limit. We don't exceed the limit. So that is why we put a delay of 2 seconds. So every twice a second, 1 reading will be sent. After another 2 seconds, another reading will be sent. Another 2 seconds, another reading will be sent. Likewise, if you are doing inside 1 minute, only 30 times you are sending the feeds. Only 30 times you are sending the values to the cloud. That means you can stay inside that limit. Is that understood, Inshaf?
Yes.
Okay. So that is why we put the limit here. So I'll put a comment also because I will share this code with you. Then if you're getting 2 readings, then you have to double this. 3 readings, again double this. 4 readings, again double this. 5 readings, again double this. Right? 6 readings, again double this. So that is why I told you, if you want to quickly respond to something, something like, let's say there's a fire or something. So every 30 seconds only you are taking decisions, in the sense that will be too late. You know, in 30 seconds, the fire can make a big damage to the properties, right? Okay, so this is the things that we need to do, and we can save this program. I will save this one in my here. I will save it. MQTT Ethernet HND51 first example. So this is the example we do. I can save it. Now you should understand, I have not attached any actual sensors to this. So we are just taking a random number means just we are taking a number and we are sending to the we are sending to the cloud, right? Okay, let's keep this one side by side. I'll go to the feeds, right? Let's go. Feeds. That's my feeds. Now we're going to get a new feed here. Once I run, there are 6 feeds now. When I run my code, you will see one more feed will appear here, right? Right. Let's compile this code and we'll make sure there are no errors. Come on, man. Right. Compiling successful. There is no errors. Let's upload it. Once I upload the code, watch this part also. Right. It is uploaded now. I'm going to open my there you can see. Okay, I have to set the baud rate properly. 9,600. Right, you need the client. We'll see whether it is getting connected. Connecting to MQTT. MQTT connected. You should get this message. Sending Photocell. Well, okay, that's the message. 0 okay, 1 okay, 2 okay. It's coming. So we should get this one here. So here only we see 6. So let's refresh this. Now you can see IoT 51. IoT 51. Our feed has come, right? Let's make this one big. Now it is our IoT devices sending information. Let's make it big. Let's open up this one. Now you can see how graph is going, right? So it's keep on going. See, I'm not doing anything. It's just going. Okay, right? So values are going, and you can see here, according to the time, according to the time, and the readings that we are taking is also getting registered there, right? Data transfer delay is also there, I guess, like every 3 seconds, like something getting registered there, right? Okay. Did you understand this, children? Right? So this is the basic part that we have done, right? Hope it is very clear, right? Okay. Now my next step is going to be, is it clear, children? Did you understand this one? Kavishka?
Yes, sir.
Insha?
Yes, sir.
Properly understood, neither. So this is the Nirmala, Yusri. Just give a thumbs up if you don't have the mic.
Understood, sir.
Right, good, Putha, right. Now, let's get back to work again, right? So let's stop the screen sharing for a while. Now, I think you again see my video, right? Okay.
Yes.
Yes, sir.
Right. So what I have in my hand is the DHT11 sensor, and I'm going to connect it to my Arduino, which means we're going to make it a small IoT device. Then we will do some work. Now, at college, we had a sensor, not a module. This is a module, not a sensor. So sensor is there here. Actually, we should have put a resistor and we should have used it in the college, right? So this one already comes with the resistor built into that. So no worries, it's already comes with the resistor here. So we don't have to put a manually resistor and use it. It's very easy. There are 3 wires. So it already shows what are the wires also. It says from this side to this side, from this side to this side, minus. Oh, it should work. Oh, come on. Right. There you can see out, middle pin is out, and plus and minus is there. So plus sign you can plug to 5 volts, minus you can plug to the what do you call that, ground pin of the Arduino, and the signal pin that we can plug it to digital pin of here something, maybe 7, then we can get the readings. So we shall do that one now, right? To do that, make sure when you're doing any wiring or plugging, now we are in the process of testing this. And you should understand now, if I turn off my serial monitor, and we should still get the feeds here. Okay, I will share the screen again. I hope you see my screen. Do you see my screen? Yeah.
Yeah.
And you can see the values still coming neither. So serial monitor, when I turned off, it still works, right? So that means if I give a 5 volt power bank, right? And if I hook my Arduino to that power bank, and if I switch it on, if I switch off my computer, still the readings will be going to Adafruit, provided that my router is on and this Ethernet cable is connected, right? Okay. Now, first thing I'm going to do is, now there is no way of stopping this, right? So there's no way of stopping this. I'm going to unplug my Arduino first, so then it will stop. Unplugged it, right? Now values stopped from coming. After 90, it didn't come. It didn't come. Now what we shall do is next, I'm going to take this one and wire it up. I'm not using the breadboard, children, right? So you also can note it down if you want. So next step, we are, that is version 2 we are doing. Actually, step 1 we already did. So the ground pin I'm putting to the ground pin. Five volts, I will put it to 5 volts here. And the signal pin, I'll put it to pin number 7. I'll turn off the screen sharing. Hope you can see that, right? So this is the sensor. So Badala, this is ash color cable is the ground. So I connected that to the ground pin of the Arduino, right? So 5 volt in, then ground 5 volt comes. So that is how I plugged it like that, right? Then this one, the signal pin, the middle pin of the sensor is hooked up to 7th pin of the Arduino. you can see orange color cable is the signal pin, right? So it's been hooked up like that, right? Yes, this is what this is how I do my work, right? So I have my work, all these things here, so I don't have to worry much how to program this one, right? So the DHC sensor, everything I don't have to remember, right? Here I have the work and the code, right? So I can refer this one and do it very simply, can be done, right? Let's get started. We are going to share the screen again. I hope you see my screen. Yeah. What we have here, children, this program, it says MQTT Ethernet underscore HND 51 underscore first example. So I'm going to go to file, save as. We'll put with DHT11. So we'll save that. Now, Vatala, remember, I have to go here, this code in, I need to do some modifications, right? So that's how you will do your work also. I wish others also here. Anyway, let us ask them to watch the video. Before coming to tomorrow's video, please ask your friends to watch the videos. Pudala, here we need to import that library, or we have to include that library, right? So we can put include, and we can say dht.h, that library is there. Now we already have done this one, downloading that library and how to call that one. We have done that, right? After doing so, we need to come here before the setup section. We can create so we can just have DHT11 object, DHT space DHT, whatever you like, you can give DHT11, or you can say DHT11. I will say DHT11 sense. File names, variable names, if you keep it small, it's good, because each character takes up 1 byte, because Arduino has limited amount of space, right? So you can say DHT1. I'll put just DHT11, right? That's it. Then we don't have much up here to do. We can go to the loop, right? We can go to the loop. One word of caution, children, when you're doing DHT, this kind of a sensor, within 1 second, if you try to get several readings, it's not going to work. Okay, so you give enough time, maybe 1 second, 2 seconds. 2 seconds is ideal. You can get correct readings. I am going to my loop section, right before my published part. I'm going to do the work. So here it is saying sending photocell value. So I'm not going to say sending photocell value. I'm going to say sending temperature value. Sending temperature, it's a value. And it's not going to be X. I'm going to use a different variable here. I'm going to define a different variable here. So we can define it up here, right? Or you can each time define and use also. I like to use a float variable, float temp. For the time being, let's put 0 there and keep it. Okay, right. Let's come down here. Now we can publish stuff, right? Okay, before we do that, we need to have value for temp. So in order to do that, we need to get the readings done. So DHT11 dot That's the method called read11. And we have to give the pin number where the cable is connected. So here I have connected to the 7th pin. So read11. If this doesn't work, there is a different library we will use. Okay. If there is a conflict with this one, there is another way to use that. I'll show you that also will work. Right. So we will say int x, in T for the time we will take like the temperature. Right. Then what we do is temp equals dht11 dot temperature. Right. That is how you take the temperature. Okay. So what we do is in the screen, if you want to print, right? So we can print temp here, temp, and we can say Celsius. Okay, you can leave a space and say Celsius. Right. That is just on the screen, right? Sending value, that value will come. Down here, you can see what we have to publish is not x++, we have to publish the temp. Temperature reading is what we have to publish. So if it is not happening, it will say failed. If it is okay, it will say okay. That means after, for example, it will say sending temperature value 31, okay, right? Likewise, it is going to give us the values. And the delay is already we have put. If you are working from a new program, please make sure that you put this line. It is very important. If you don't have this one, you will lose the limit. Then you will have to wait for another minute to continue your practicals, right? Okay. Right. Ahlak is having a power cut, so he will join, I think. Right. Right, children. So that's the basic part, right? Let's hook up this one and let's give it a try and see. So this is also going to send the information. You should understand it is going to send the information to the which part? To the feeds IoT 51. That means we are getting the temperature readings. Okay, we're going to get the temperature reading, right? So this is the feed where we're going to get that value. Nice. So nothing much to change there. So let's save this one and let's me hook up the Arduino. When I hook up this one, it will try to send that again. Right. So I will upload the new program. Then I will keep this on one side. It's compiling still. Let it compile. And this is the feed. Now we don't have any feeds coming there. You can see, I think it's starting to come. No. Right, 32 are registered. Now readings are coming. It's really hot inside my room, right? So 32 is coming. 32 is coming. Then it'll go a flat line like that because 32 is the reading that we are taking. Okay, so if you can do up to this level means it's a great success in your assignment. Okay, right. So we are doing this one, right? Okay. Now, now there is one reading we are taking. I will show you how to get two feeds, right? So then I will show you how to put it to the what do you call dashboards and all the things. So we will try to do all those things today. So tomorrow we can do it in the physical class. Again, we can do it as a summary or like a review or a revision. Like I can do it once again, right? Up to this point, did you understand, children? Is it understand? Right? Right. Okay. Inshaf. Okay. Good. Kavishka. Nirmala. Right. Kavishka. Clear the Buddha. Right. Okay. Okay. Right. Good. Good. Right. Nice. Then mama then ice cube bag gala with the make a temperature mama then make it a blow blow temperature value. you can see this reading here, or as well as this particular graph will go up. So I'm going to hold it inside my hand. Let's say whether it is increasing. I think high අල්ලගෙන ඉන්නේ. බලමුකෝ වැඩි වෙනවද කියලා. සමහරට වැඩි වෙයි. 32 ම තමයි තාම තියෙන්නේ බලමු. ඒක වෙලා යනවා මම ඒකට I'm going to okay 33 ගියා. 33 is registering. You can see, I think up to 34 we are registering there. 34 registered. I will blow some cool air now. මගේ වීඩියෝ එකක් පේනව නේද?
Yes, sir.
But, you can see the graph is dropping now. Graph is dropping. So real time it is, we are getting the feeds. Right, okay. 32, 33 තමයි අඩුවෙන් නෑ මාර රස්නේ නැතින. හරිද? Right. Okay. I'll open the door a little bit and see. It'll take some time to cool down again, right? Okay. Basically, that is what I wanted to tell here. අපි code එක චුට්ටක් වෙනස් කරමු. Let it go like this. Let this data go, no problem. We will come to the code in here, children. Right now, I took only one reading, which was temperature. I'm going to take another reading, which is going to be humidity. Let's say float, humid. That's also, I'm going to put 0 now here. I'm going to take two feeds now, two feeds. Now let's go down here. Here I'm going to take humid is equals to dht11 dot humidity. Very easy to read like that, right? Get the humidity reading. Now the thing is, we are having one MQTT object, which is IoT 51. This is for temperature. Okay, so if you want to send another feed with a different name, then you have to create another MQTT object, which is up here. We come here. No, don't worry, just we can simply do that. We come over here, nicely come here, right? Let's copy this and paste it, and let's change these things, right? Let's call this one as P, and let's call this one as H. Okay, so, and we can call this one as IoT 51 temp, IoT 51 humid, and the existing one we can delete it. Right, so I like to have this one over here as well, right? So it's very properly done, right? So I have two Adafruit MQTT published objects. One is temp, the other one is humid, right? Make sure you have different feed names given here. So we don't need this, right? Now let's go down here. We need to do something like this. Now we are publishing temp here, no problem. So we have to say temp here. I'm going to copy this, right? And I'm going to paste it. This is going to be humid. And here I should give humid. Then make sure I change the delay to 4000 because I'm getting two feeds, not one. So I'm getting two feeds. So make sure that I change to 4000. Okay, I change to 4000. Now what we're going to do is we're going to let's change that to okay. Let's change that. Let's change that things, right? So I like to put this one as well, right? So let's copy that. Let's make a copy of this and put it here. This is for our testing purpose. We're going to get it recorded or get it displayed on the screen, right? That's it. I'm going to say humid. It will be displayed in percentage. I think it will be working fine now. Let's go to our feed section. Now the feed is still coming. 32 is still the reading is coming. I need to go to my feeds. I have 7. With these 2, I will get 9. Doesn't matter, right? So later I can delete them. Now I'm not going to delete them, right? Let's go to feeds now. You can see 1, 2, 3, 4, 5, 6, 7. I already have. With these 2, I'm creating temp and humid. I will be getting 9, altogether 10 possible, right? So it's okay. I'm going to get that, right? Let's compile this and see there is no errors. Right, there is no errors. Let's upload the code now. I think it's getting uploaded. Good. Now let's open the, okay. Let's open, oh, what is busy? Okay, still uploading, is not done yet. Okay, now it is there, right? It's working, cool. Let's reload this and see whether we are getting that. 2 feeds, right? We got them. You can see here, IoT 51, humid is coming. IoT 51, temp is also coming. Temperature is also coming. And you can see in here, these are the values that we are sending, 32 centigrades and 95% of humidity. So if I open the humidity here, earlier I showed you the temperature. So let's open the humidity feed now. Oh, I'm having a power cut. Okay, luckily it came back. Right. Can you still hear me, children? Hello.
Yes, I can hear.
Okay, thank you. Putala, you can see there's a flat number coming because a flat line is going on because it's 95 itself, right? I'm going to blow some air to that. So see whether the, but every 4 seconds only it will change because that's how we have programmed it. I think you can see I'm going to blow this. $95. Temperature going up. Temperature 94. I think can't change the humidity. Don't know why. It's really hot today anyways. Okay, seems no luck there. Temperature we had a change, right? No problem. Okay, right. So that is how you get the readings up to the feeds, right? Right. Let my IoT device run here. Let my IoT device run nicely like that. And I'm going to go to this full screen mode now. Now let's go to something like dashboard. Okay. Now I think according to my profile, I can create 5 dashboards. So I will create a fresh dashboard for you. I will create a fresh dashboard for you. That's how you will be doing as well. So what you do here is Adafruit as basic dashboard. How do you create one? You can create a dashboard. View all dashboards. Let's click on this one. Let's see whether we can create one. Yeah. Yes, I think it's giving us. Input, output. Dashboards. View all. No. Give me a second, children. We can do that. Okay. How did that come? When you basically go to the IO here, when you go to the IO here, don't go to dashboards here. Okay. Don't go to dashboards here. Go to IO here. Once you go to IO, you will see that's my username, and this is the dashboards. These are the available two dashboards available now, and you have to hit the new dashboard button. Once you do that, it asks for the example, right? So I'm going to say HND 51 IoT demonstration. Let's say IoT demo. Right. Let's what is the date today? 20th, right? So let's create that dashboard, right? That got created here. Then what you need to do is, you will, at the first time when you're creating, you will see only the dashboard that you have created. You can click on this dashboard and you will see an empty area like this. Then what you need to do is, let me switch to my other camera. Right. So we need to create a dashboard with the gauges where we can read the readings. So we go here, we click here. See, there's a mark here. You're watching my screen, right? You're watching my screen. So I'm going to click this one. Then you select create new block, right? Not layout, create new block. Each block you can create. So when you create a block, there are plenty of things that you can put. Now you should understand certain ones if you want to work. For example, if you want to do the maps and all, you have to have the Adafruit hardware to do this one. Okay. So third-party hardware, we can't 100% guarantee that it will work with and it will be compatible with that. These easy ones like on-off, resets, and like these gauges will simply work. I'm going to simply use this one. Right, this is the most commonly one that we use, and this line chart also we can use. I'm going to use this one, right? Gauge. Then once you select that carefully, I think you are writing down the steps, or we are noting down the steps. So we went to IO part, then we created a dashboard. Then by the time we want to created the dashboard, we gave the name. Then we clicked on that and we came here. Now we click here, and what we do is we click on create new block, create new block. So when you do this, we can select the gauge that we want according to the visualization that we need, how we want to depict the data, or how we want to represent the data visually on the screen. Even in your mobile phone, it looks really nice. Okay, so we're going to click this, right? So we're going to hit this gauge. And it shows all the available 1, 2, 3, 4, 5, 6, 7, 8, 9. I have used 9 out of 10 my feeds. So what feeds are we going to use here, right? I think one at a time we can do this, right? So not both. See, once I select one and I select the other one, it automatically gets removed. Let's work with the temperature first, right? So let's hit IoT 51 temp. Last reading was 34. Okay. Then I'm going to hit next step. When I go to the next step, it says in this final step, you can give your block a little title and see a preview of how it will look. Customize the look and feel of your block with the remaining settings when you are ready. Click the create block button to send it to your dashboard. So we're going to create a nice dashboard, gauge, and put it in our dashboard. We can see that. Right, title, we'll say room temperature. Okay, my room temperature. Okay, lab temperature, my lab temperature. What is the minimum value we are expecting to hear? This is we are in Mount Ella, so it's no way it's going to go for 0, right? So not even it's not going to go for 20. Someone in Nuvarelia, you might go to 20, but I'm not sure. Some people left, I think, power cut. Okay. Inch of history of cut. I think we can continue neither because it is getting recorded neither. Shall we continue?
Okay.
The 10 minutes maximum, Putala. We'll continue.
Okay.
Ne?
Yeah.
Okay. So minimum value, we can set it. If your minimum value is like 20, you can set it, no problem. 20 is the minimum value. It doesn't matter. It's always need not to be 0. So I can give, I can't delete that 0. So I don't know. Right. 20 is the minimum value. Right. So it's up to you. There was 0. Right. If you like 0, you put it 0, no problem. Right. 20 is the minimum. Maximum value, right? So temperature maximum 100. If it goes, we can't live, right? So let's say we will put to something like 44. Yeah, 40. So once it's set to 40, it turns to red, right? So and the thickness of this one is how many pixels it's asking. 10 means slim, and 50 means very thick, and 75 is very thick, right? So 25 seems all right. I'm going to put here a sample value. You can see if I put something like 22, it will show like that, right? And low warning value. Low warning value means if it goes beyond that value, we have to give a warning. Let's say below 25, it's a warning, so it turns to red. High warning value, let's say above 30, let's say above 32, right? Above 32, let's say it's alarming, right? Okay, so you can set those values as well. Those are optional values. If you want to display decimal places, we give 2 decimal places, 2 decimal places. So that's fine, 2 decimal places. And you can put a test value here and check it out, right? So for example, if I put 35, I'm sorry, let's put 35 here, then it goes up there. If I put something like 27, and you can see it is coming up to that level, 28, that is fine. So I'm going to create my gauge like this. It's done. So I'm going to scroll it down and I can select right. So I have not put any icons for that. So I'm going to click block. So create block here. So in my dashboard, one is a bit, now the reading is 34. Sorry, it's really hot, right? So it's really hot. So it's 34 showing, no problem. Let it be like that. So recommended values, let's say 32. Now we're going to get the next one as well, right? So we're going to get the next value as well, right? So watch this. We go here and create new block, and same thing we will take, and this time we're going to choose humid, and we'll say next step. Let's say lab humidity. Gauge minimum value, let's say it should not drop below 50, and maximum is 100, no problem. Gauge, that's the same thickness, or if you want, you can make it less thickness like that. Yeah, we will keep it like this for this. And you can put gauge value here. You can put it to percentage. I forgot to change this to Celsius here. I will change that. Low value warning, let's say if it goes below 60, it's dangerous, and if it goes below 95, above 95, that's also dangerous. Let's put a value like 99, so it's a dangerous value showing. Let's say 75 is a okay like value showing. So after doing so, you can simply go down here and say create block. That will be done, right? Then I want to change, edit this, right? So you go here. Edit layout. So if you want to make a change, go to click this, edit layout, hit this, edit block, right? So same thing, go back. I want to change that to Celsius. That's all, okay. So now it's coming nicely like that, save layout, and I can go here. I can click like this, and I can click on edit layout, and even I can place it nicely like that. So it looks very pretty like that. So even you can make it smaller. That's the smallest size, I think. Or if you want, you can make it bigger as well. So we will keep it up to that point, right? So that is how you put it to gauge as well, right? So that's the maximum part that we can do up to in this practical. So if you can do up to this level, that will be great. Okay, if you can do up to this level, it will be great. Later, what you have to do is from the feeds, you can go to the feeds, you can go to the relevant feed, and still we are getting the data. I went to the wrong feed. Feeds IoT, this one. Here we are getting the feeds, right? Nice. So this kind of a graph we can take. You will put this one to your screenshots. You will discuss about this, why it happened, how it happened, and how your IoT device is responding, and other things, what's happening, right? So in our upcoming practicals, we will put LEDs and we will see how to do the subscribing as well. Okay, right. Now what you need to do is you need to go to the Adafruit platform and just take a look at them. And I think you don't have the hardware equipments to send data and do the practicals, right? So I think it's pretty easy when you're working with the Ethernet shield. Now, if you're using a GSM module or something, isn't it, Inshaf, there's a huge amount of wiring we have to do. Now here there is no wiring at all. Just take the thing and plug it, then it is ready to work. Okay, so that is why we are asking you to buy this Ethernet shield, even for your degree. Then it will be useful, and you know things are skyrocketing these days, so better buy one and keep for your practicals, right? Having said that, I can wind up for today's lesson. Do you have any questions, children? And you can tell me your small feedback about how was the session as well. Then we can formally conclude the session. Then I can upload the video link to your, what do you call,
Session was understood, sir. Thank you, sir.
Huda, you understood very well?
Yeah, sir. Very well. Session understood very well, sir. Thank you, sir.
Okay, good, good. Others also, can you confirm me whether you understood it well?
Yes, sir. Understood well, sir. And your setup also fine, sir. That dual camera and all. I didn't expect this, how we can do practicals through online. But thank you for your support and all, sir.
Whatever we do, we have to do it properly, otherwise no use neither.
Yes, sir.
Okay, I'm happy that you liked it, right? Anyway, I'll try my level best to do it. Then, what about you, Puta and Yusri?
Yes, well understood.
Okay, then tomorrow, most probably we can come to college. Then there also everything is ready. I will bring this device also there, so you can use this Ethernet shield. So you can do the practicals and get it done, right? Okay, if there is a possibility, talk with your team and buy the devices. And tomorrow after practicals, if time is remaining, we will have a discussion on your proposals, and I will help you how to do the proposals and get going with the assignments. Okay. Okay, children, then thank you very much. Be safe, right? So be safe and have a nice day. See you in the class then. Bye.
Okay, thank you, sir. You also be safe, sir.